Hello everyone, welcome to lecture 2.2 of testing of hypothesis large sample. In this lecture, we are going to do two problems under the topic test for the significant difference between two means. Problem: a sample of heights of 6,400 Englishmen has a mean of 170 centimeters and a standard deviation of 6.4 centimeters, while a sample of heights of 1,600 Australians has a mean of 172 centimeter and a standard deviation of 6.3 centimeter. Do the data indicate that the Australians are on the average taller than the Englishmen? So here it is given two samples, Englishmen and Australians. Englishman sample size is 6,400. N1 is 6,400 and this sample size is 1,600, that is N2. And the mean of first sample X1 bar is 170 centimeters and the mean of the second sample X2 bar is 172 centimeters. And the standard deviation of the first sample S1 is equal to 6.4 and the standard deviation of the second sample is 6.3, which is S2. So now we have N1, N2, X1 bar, X2 bar, S1 and S2. So here the N values are N1, N2 are greater than 30. So it is coming under large sample. In large sample, we are going to check the mean, difference between mean. That is the question, do the data indicate that the Australians are on the average taller than the Englishmen? So we are going to check the average here, mean here. So it is coming under the topic test for significant difference between two means. So now we'll write the given data. First step, one, given data N1 is equal to 6,400 and N2 is equal to 1,600. X1 bar 170 centimeters, X2 bar 172 centimeters and S1, the standard deviation of the first sample is 6.4 centimeters and S2 is 6.3. So now second step, write the null hypothesis and the alternative hypothesis. So here always H naught, something is equal to something. Here we are going to check the difference between the mean of two samples. So always we'll write the parameter of the population. So mu1 is equal to mu2 is our H naught. And H1, it may be not equal to or less than or greater than. Here the question is, do the data indicate that the Australians are on the average taller than the Englishmen? The question is, Australians are taller than the Englishmen or not? That is the question. Here we are taking Englishmen as sample 1, Australians are sample 2. So we have sample 2, mu2, mean of the sample 2. Mu2 should be greater than mu1 or not is a question. So always we'll write the first sample first. So mu1 is less than mu2 is our H1 alternative hypothesis, which is one-tailed test, left-tailed test. So here we have in this problem, mu1 is less than mu2. That is left-tail test. So now we'll go to third step. The formula Z is equal to, here we have N1, N2, X1 bar, X2 bar, S1, S2. So instead of sigma 1, sigma 2, here we have S1, S2. So the formula is X1 bar minus X2 bar by root of S1 square by N1 plus S2 square by N2. If you know the population standard deviation, then we'll use that here, sigma 1 square, sigma 2 square. Here we have the sample standard deviation, so we are using S1 square, S2 square here. X1 bar is 170 minus X2 bar is 172 by root of S1 square is 6.4 the whole square by N1 6400 plus S2 square is 6.3 the whole square by N2 is 1600. Now we'll find this value. For the numerator, put this bracket 170 minus 172, close the bracket, divided by square root of, this first bracket is for the whole term, square root term, and for the first term one bracket, then for the numerator another bracket, 6.4 the whole square divided by 6400, close the bracket for the first term, plus for the second term one bracket, and for the numerator another bracket, 6.3, close the numerator whole square term divided by 1600. So second term closed, and one more bracket for the full term. Now we'll find the value. It is minus 11.3, which is equal to minus 11.3. So Z value is minus 11.3. Now we are going to find the table value. The level of significance is not mentioned, so we will take 5% level of significance. So the table value of Z at 5% level of significance . Here it is left tail test. So the value is minus 1.645. So the calculated value Z is equal to minus 1.3, which is less than minus 1.645, which is our table value. So in left tail test, if we have less than, then the conclusion H0 is rejected. So H0 is rejected, then H1 is accepted. So what is H1? Mu1 is less than mu2. That is, Englishmen are smaller than Australians. That is, Australians are on the average taller than the Englishmen is a conclusion. Australians are taller than the Englishmen. That is the conclusion. The mean produce of wheat of a sample of 100 fields comes to 200 kilogram per acre, and another sample of 150 fields gives a mean of 220 kilogram. Assuming the standard deviation of the yield at 11 kilograms for the universe, test if there is a significant difference between the means of the samples. So here two samples are given. This sample size of the first sample is 100 fields, and the second sample size is 150, and this is the mean of the first sample 200, and this is the mean of the second sample 220, and it is given assuming the standard deviation of the yield at 11 kilograms for the universe. So the population standard deviation is 11 kilograms. So we have N1, N2 and X1 bar, X2 bar and sigma. So we are going to check the difference between the means. It is asked, find, is there any difference between the means of the samples? So here N is greater than 30 and we are going to check the means. So it is coming under the topic test for the significant difference between two means. Now we'll write the given data. N1 is equal to 100. N2 is equal to 150. X1 bar is equal to 200. X2 bar is equal to 220. And the standard deviation of the population sigma is 11. So we have here only the standard deviation of the population. So now second step, H0. H0 is the null hypothesis. We know always this in H0 something is equal to something. Here we are going to write the population parameter, that is mean. We are going to check the means of two samples. So mu1 is equal to mu2 is H0 and H1 is there any significant difference or not is a question. So mu1 is not equal to mu2. So it is two-tailed test. Third step, we are going to write the formula Z. So here we have X1 bar, X2 bar and sigma. We don't have two sigma values or two S values. So we are going to use case 3 formula, X1 bar minus X2 bar by sigma into root of 1 by N1 plus 1 by N2. This is a formula which is equal to X1 bar is 200 minus X2 bar is 220 by sigma is 11 square root of N1 is 100, 1 by 100 into 1 by 150. So now we'll calculate this. For numerator, 200 minus 220, close the bracket, divided by 11 into square root of, for the first term, 1 bracket, 1 divided by 100, close the bracket, plus second term, 1 divided by 150, close the bracket. So one more bracket we'll put for this square root term. So now the value is minus 40 into root of 15 by 11. If you find the decimal point, it is minus 14.0835. Minus 14.0835. So here two-tail test, we need mod Z. So what is mod Z? Mod Z is equal to 14.0835 or 14.08. The next step, write the table value. Here the level of significance is not mentioned. So we'll take the 5% level of significance. Table value mod mod Z. The table value of mod Z at 5% level of significant is 1.96. So the calculated value Z is equal to 14.08 mod Z 14.08, which is greater than 1.96, the table value. Therefore, for two-tailed test, if you have greater than, then it should be H0 is rejected. Then H1 is accepted. So what is the conclusion? There is a significant difference between mean of the sample. That is the inference. There is significant difference between the means of the sample. Means of the samples. That is the answer. Inference. Thank you.